Assalamualaikum, my name is Siti Fatima binti Kadir. I will explain about programmable logic device. The first one is definition and advantage of using PLD compared to standard IC and custom IC, and general characteristic of a PLD. Programmable logic device. Definition of programmable logic device is PLD, short for programmable logic device, a generic term for an integrated circuit that can be programmed in a laboratory to perform complex functions. A PLD consists of arrays of AND OR gates. A system designer implements a logic design with a device programmer that blows fuse on the PLD to control gate operation. A PLD has an undefined function at the time of manufacture. Before the PLD can be used in a circuit, it must be programmed that is reconfigured. PLD types can be classified into the following groups. Number one is PROMS, is programmable read-only memory. These programs can offer high speed and low cost for relatively small. Number two is PLAS, is programmable logic array. This can offer flexible features for more complex design. Number three is PAL or GALS, is programmable array logic or generic array logic. It offers good flexibility and are faster and less expensive than PLAS. The advantages of using PLD compared to standard IC and custom IC is cost of production, the cost to produce the mask used in the process photolithography, and the cost of the designs. PLD producing design which chip do not need any mask ASICs, which is one or two masks need to continue cells available on silicon surface, and wire designers have to be continued between cells. Cheap labor costs. LBAM need design all masks. Mask generate and processing costs are high. Two is fast design time. The general characteristic of a PLD. The circuits in a fixed logic device are permanent. They perform one function or set of functions. Once manufactured, they cannot be changed. Next, the design can be quickly programmed into a device and immediately tested in a live. Next, no need for a common mask layer is designed, and very quickly in the design. Then is a large block of internal connections that can be in the program, and requires a device that consists of micrometric cells. And the last one is PLD, is the input and output that can be programmed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Munimas Inan Yusuf. I'm going to present about architecture PLD, which is regarding about floor plan, level of different part, and its block diagram and the architecture from PL and PLA. Also, I'm going to present about methods of programming the PLD, which is methods of downloading and language programming.
Architecture PLD. This figure shows floor plan and label. This is the block diagram of architecture PLD. The figure below shows architecture diagram of PROM, which is programmable or plan, followed by a fix and plan. This is architecture diagram of PLA that contains two levels of logic, an AND plan and an OR plan where both levels are programmable. This architecture diagram of PAL, programmable and planned, followed by a fixed OR plan.
Assalamualaikum warahmatullahi wabarakatuh. My name is Eralazina binti Asnab. Today I will explain about the method of programming the PLD, which is the method of downloading and the language of programming. Methods of programming the PLD. There are three methods of programming the PLD. Boolean expression technique. Most of the logic can be described using AND gate or OR gate. PLD will convert the product of the number of operations and carry out optimization for device or chip program. Then transfer the Boolean logic pattern into the programmable device. Simple expression of AND gate is A multiply B and OR gate is A plus B. Secondly, truth table technique. Input and output relation of PLD can be obtained by reading the truth table and generate an equivalent logic configuration. Schematic editor technique. Draw the schematic design of a logic device PLD. Types of design language. There are two types of design language. Firstly, high-level language. CUPL, frequently used for low complexity device. HDL and VHDL are popular higher level description language for more complex device. And PLD language can be programmed in a laboratory to perform complex functions. Secondly, low-level language, assembly language. There is a very strong correspondence between the program statement and the architecture mentioned code.
Assalamualaikum, my name is Nurul Fadila, and the topic that I will explain is about method of storing memory in PLD, and this subtopic is include of famous, anti-fuse, metal anti-fuse, and polydiffuse anti-fuse.
Method of storing memory in PLD. Gate avalanche injection MOS transistor, or known as FAMOS. So this is the physical structure of FAMOS transistor of polysilicon wire, metal, source, drain, and P substrate. Of FAMOS transistor, it operates in two conditions, which is charge condition and discharge condition. Charge condition, when a high voltage is applied between the source and the drain, some charge will be induced in the second gate, causing the transistor has a channel that is conductive. For the discharge condition, EPROM can be erased by exposure to the UV light, and this turns oxide into a conductor, which causes the charge stored in the bottom of the gate to become floating. EPROM uses a floating gate avalanche injection MOS FAMOS transistor cell to store charge. Applying a special programming voltage VPP cause a high electric field to be developed in the channel region of this transistor. This in turn causes electrons to jump the silicon dioxide barrier between the channel region and the floating gate. During programming, the select gate is given a positive bias which helps attract this electron to the floating gate electrode. Because the floating gate is surrounded by silicon dioxide, an excellent ice insulator, the injected charge is effectively trapped. The storage period is projected by Intel to exceed 20 years. Cells with trapped charge cause the transistor to be biased on, whereas those cells without trapped charge are biased off. Blank EPROMs have no trapped charge and each cell stores a logic 1. The EPROM electron on the floating gate absorbs photons from ultraviolet light source and acquire enough energy to reverse the programming process and return to the substrate. Next is antifuse, metal antifuse, and polydiffuse antifuse. Usually it is open circuit and it is a category of non-volatile which is permanent, and it has two rules of polydiffusion antifuse and metal-to-metal antifuse. And this is the structure of antifuse. Consists of metal 2, metal 1, antifuse, substrate, polysilicon, diffusion, antifuse dielectric, and field oxide. Metal antifuse. An antifuse is the opposite of regular fuse. It is an open path until a programming current is forced through it by applying a high programming voltage across it. An oxide nitride oxide (ONO) dielectric which is sandwich of will block the flow of current from polysilicon layer towards diffusion layer. The dielectric will be melted when receive the programming current and permanently create an electrically conductive path. And in this metal antifuse, it consists of polysilicon, ONO dielectric, field oxide, and plus diffusion. Is polydiffuse antifuse. A metal-to-metal M2M antifuse is formed using programmable link. The M2M antifuse is used as a programmable device in an FPGA, where it places between two interconnect metal layers of logic CMOS process. The resulting program link is an alloy of amorphous silicon and barrier metal that forms a low resistance path between the logic circuit, which is tungsten, titanium, and silicon. The M2M device may then be programmed to interconnect logic circuit. In this polydiffuse antifuse, it consists of metal 1, dielectric oxide, and metal 2. That's all from us. Thank you for watching.